need to get like terms. And by like terms, I mean same radical parts. Okay, there are two easy steps to follow to do that. One is, the first step is to simplify the radical, if possible, and the second step is to just add or subtract the radical expressions. So, for example, let's take a look at this example. I have 3 rad 7 plus 7 rad 7. As you can see, rad 7, we cannot simplify it. So we just keep it like that. So step 1 is already done. You can think of it like this. 3 of something plus 7 of something gives me what? 10 of that something. So I would have 10 rad 7. It's the same thing with cube root or if I have any other index here instead of 3 or 2. So I have 12 cube root of 13 minus cube root of 13, which means I have, we actually have a 1 here, but we don't write it. So it's like 12 cube root, 12 of something minus 1 of something gives me 11 of that something. So I would have 11 cube root of 13. The previous examples that we did were easy because we didn't need to simplify anything. But there will be times that the radical parts are not the same. But if we try to simplify them, we will end up with radicals that are the same and we can combine them. Let's take a look at these two examples. For example, for the first one, I have rad 8 plus 3 times rad 32 minus rad 2. Let's try to simplify the radicals first. So for rad 8, I can simplify it, I can rewrite the radicand as 4 times 2 because 4 is the largest perfect square that is hidden in this 8. So I can write it as 4 times 2. And then here, I have 3. Instead of 32, I can write 16 times 2 because 16 is the largest perfect square in 32. 16 times 2, and then the rad 2, I will keep it the same way. And then here, I can break down these two radicals to 2 separate radicals, each of them. So that would be rad 4 times rad 2 plus 3 times rad 16 times rad 2 minus rad 2. And then this 4 would give me 2. So I have 2 rad 2 plus this 16 would give me 4. So 3 times 4 rad 2, this rad 2 minus rad 2. Again, I will have 2 rad 2 plus 12 rad 2 minus rad 2. So I would have 14 rad 2 minus 1 rad 2, so I would have 13 rad 2. Okay, now that we're done with the first example, I'm going to erase this to do the second one. I'm just going to write the final answer in front of it. So that's 13 rad 2. Okay, here we have cube roots. Cube root of 81 plus 5 times cube root of 24. There's a 1 here, but we don't write it. Okay, so the largest perfect cube in 81 is 27. So if I divide 81 by 27, I would get 3. So that's cube root of 27 times 3. And then plus, I'm going to keep the 5 and the cube root. And then instead of 24, the largest cube root in 24 is 8. So if I divide 24 by 8, I get 3. So I can write it as 8 times 3. And then I can break down the radicals. So I would have cube root of 27. Let's actually write it there. Cube root of 27 times cube root of 3 plus 5 times cube root of 8 times cube root of 3. And this is a perfect cube, so I can just write it as 3 cube root of 3 plus cube root of 8 is 2, so it's 5 times 2. 5 times 2 cube root of 3. And then 5 times 2 is 10. So I will get 13, I don't know if you can see it here, but 13 cube root of 3. I have 2 more examples here for you. You can pause the video and try to do them, and then we'll go over it together. Alright. 3 rad 125 minus 7 rad 80. So I'm trying to simplify the radicals first. So for the first one, I'm going to write the 3, but for 125, I know that the largest perfect square in 125 is 25. So 25 times 5 will give me 125. And then in the second one, instead of 80, I can write it as 16 times 5 because the largest perfect square in 80 is 16. And then I'm going to break down each radical. So I would have 3 times rad 25 times rad 5 minus 7 times rad 16 times rad 5. And as you can see, I have the like terms that I was looking for. So I'm going to simplify the rest. So rad 25 is a perfect square, so I would get 5 out of that. So I have 3 times 5 rad 5. And 16 is also a perfect square. And I get a 4 out of that. So I have 7 times 4 rad 5. And then here, as you can see, 3 times 5 is 15. So 15 rad 5. And then 7 times 4 is 28 minus 28 rad 5. So I have 15 of something minus 28 of something, which gives me negative 13 of that something. So this is it for the first example. The second example is rad 48 minus rad 2 plus 2 rad 75. So the coefficients here are 1 and 1, actually negative 1 for rad 2, but we don't write them. So let's try to simplify them. So for 48, the largest perfect square that is in 48 is 16. So if I divide 48 by 16, I would get 3. So instead of 48, I'm going to write 16 times 3 minus rad 2 plus 2 times, instead of 75, I can write 25 times 3 because because the largest perfect square in 75 is 25. So 25 times 3, and then I can separate the radicals. So here I have rad 16 times rad 3 minus rad 2 plus 2 times rad 25 times rad 3. 16 is a perfect square. I'm going to write here because I need more space. And it gives me 4. So 4 rad 3 minus rad 2. And then here, 25 is a perfect square and it's 5. So this one would be 5 here. And then 5 times 2 is 10. So plus 10 rad 3. And then as you can see, the only like terms that I have are in this one and this one. So 4 of something plus 10 of something is 14 of that something. So I would have 14 rad 3 minus rad 2. And we cannot simplify it